Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 18, 2025, about 4 days ago. The standout is a layout-guided, multi-view, multi-modal diffusion system that turns a 3D layout and a reference image into realistic, semantically consistent indoor scenes across arbitrary viewpoints. The paper is titled, SPATIALGEN, Layout-Guided 3D Indoor Scene Generation. And as we will see later, the results are really impressive. Beyond the model, the authors introduce a massive synthetic dataset with more than 12,000 scenes and millions of photorealistic renderings, enabling stronger training and evaluation. Also, the authors shared the code on GitHub. You will find installation steps, requirements, and model downloads, plus inference scripts for image-to-scene and text-to-scene, a small test dataset, and a layout visualization tool. The repo includes configs, pre-processing, Docker files, and a README with release notes and licensing. On Hugging Face, SPATIALGEN 1.0 is downloadable with diffuser support, plus dataset links and scripts for image-to-scene and text-to-scene inference, with clear install steps and examples. Figure 1 introduces what the system delivers. Controllable 3D indoor scenes that match a target layout, with results that look photorealistic and stay consistent across many views. The left column shows text plus layout guiding a living room, which means a short description steers style, while the layout locks object placement. The middle column uses a single reference image with the same layout, so the appearance transfers. The right column transforms a real video by first estimating its 3D layout, then generating a fresh scene. Table 1 compares indoor datasets and makes the point that scale and annotations drive controllable 3D scene generation. The table highlights that the new synthetic set offers the most scenes and panoramic videos, which matters because multi-view coverage teaches consistent geometry and semantics. Real collections provide realism but lack views or complete labels. Synthetic sets vary, yet this one pairs large size with full 3D layout and object annotations. Figure 2 shows what the dataset actually contains, which matters because training needs broad, well-annotated coverage. The floor plan on the left visualizes a smooth camera path, with many sampled viewpoints that trace realistic room navigation. The colored 3D layout below encodes object boxes and walls, meaning the dataset records precise spatial structure. The right column presents panoramic renderings, so each viewpoint includes photorealistic color plus labels for depth and semantics. Figure 3 shows the full pipeline that turns a 3D layout and one or more posed images into a consistent 3D scene. The left panels provide the layout and an input image, which are rendered into coarse semantic and scene coordinate maps, meaning per pixel labels, and global 3D coordinates for each pixel. The central block runs a multi-view, multi-modal diffusion module that alternates cross-view and cross-modal attention, so appearances, geometry, and semantics align. The top right adds iterative dense view generation using cross-view guidance, and the bottom right reconstructs the explicit 3D scene. Okay, 2 takeaways stand out. Layout guidance plus multi-view. Multi-modal diffusion delivers photorealistic scenes that stay consistent across views and modalities, and the large synthetic dataset with precise 3D layouts makes that possible at scale. The implications touch VR, robotics, and design tooling with controllable scene generation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.